Hi, good morning, everyone. My name is Luke Smith, in case you didn't meet me yesterday. I'm one of the engineers on the YUI team. Today, I'm going to be talking about debugging in the YUI3 environment. To be honest, a lot of the content in this presentation is going to be just sort of debugging in general, web application debugging in general, because YUI3 is just more web code, right? So the techniques that I'll talk about in here are really applicable across any web development that you're using. The YUI3 environment does use some idioms inside, and the best practices that we use sort of expose the code in certain ways that might cause certain debugging patterns to be more prevalent or more necessary in the ways that you're debugging your code. So before I get started, I did want to mention that the next version of YUI3 will not have any bugs, and so therefore the code that you write with it will also not have any bugs. So you can just keep this, just for posterity's sake, or just to know that you can't trust what I say. So it turns out that web development is actually really hard, and this may come as a surprise to some of you, because it was only just a couple of years that we were all happily writing our little global functions and our little scripts and having our event handlers right there in our DOM and all of that sort of stuff, and it just seemed to work fine, right? And then we, had to deal with other browsers and things like that. So this is what we're up against nowadays. So we have HTML, which you have to understand how the browsers might interpret the tag soup. You have to worry about the doc typing. And the different versions of the browsers that come out will support different levels of markup. The newer browsers are going to support HTML5, canvas tag, and all sorts of other coolness like that. Same thing with CSS. We as developers have to understand how the cascade works, how specificity rules work, understanding stacking contexts and box model, and this also applies across browser versions, of course. You have Safari, for example, is coming out with their animation model and how those things come into play. JavaScript itself is a beautiful language. I love it to death, which is probably pretty obvious considering the team I work for. But it has some real nuances that really catch a lot of people by surprise. And I certainly find myself explaining these things to a number of people in the chat groups and in the forums and things like that. And I can spend a good hour or so just talking about understanding what this word means. Seriously. And then on top of that, we have the modules that live on top of JavaScript inside of the browser engine. So we have the DOM module and its particular quirkiness across the various browsers. Maybe we have a different API here or there. And from the debugging standpoint, it's really useful for us to know and understand how page reflows and DOM reflows work and the idiosyncrasies of the event system. And the fact that a lot of what happens in the browser environment is asynchronous by nature. And a lot of the code that we're going to write and the utilities that we present for you are also going to therefore be asynchronous. And so being able to understand that while JavaScript is a single-threaded language, there's a lot of asynchronicity introduced by the event system and by XHR, for example, and knowing when it's appropriate to expect a return value and how to handle those sorts of things. So I've talked already a little bit how the browsers have various implementations. They also have different security policies. Maybe you're developing in one browser and you want to inspect some content of some external file and works just fine. Well, that won't work on another browser because they have a different security policy that might restrict access to the content in that file. And of course, browsers have bugs, which also may come as a surprise to some of you. So then the last part that we have, which is kind of, I think, definitely more of a benefit than anything, is the library itself. But of course, once you introduce a library into the environment, you are working with another piece. And the library is going to introduce its own idiosyncrasies. And from version to version, we're having to deal with the different browser versions that we're normalizing against, and so there are changes that are necessary. We can take advantage of the changes from browser version to browser version to give you better optimization in things, but it still is often relevant to know what changes happen from version to version. So if you end up working with an older version of the library, this method that you're so used to using, well, it just doesn't work anymore, and maybe you can't upgrade, and you have to deal with those things. And of course, libraries are also software, and therefore they have bugs. So we can take that one home. Software has bugs. So the environment that we have to work in is really complicated. There's a lot of complexity in all of the different pieces that we're working with. And there's inconsistency across the browsers that we have to deal with. And of course, there's bugs all over the place. But this doesn't actually touch on what you have to be responsible for, which is the actual problem, right? You are given a task, an assignment, an application that you need to build. You have a problem space that you need to work in. Your job is to take an idea and turn it into something, right? And that's the web application. That's the end product that you have to worry about. But the environment that you're building on sucks. It's really awful. So what we try to do is we try to normalize the playing field for you, or give you an advantage over how awful the environment is, and we try to reduce the amount of required knowledge that you have, that is required, well, the amount of knowledge that is required to deal with the browser idiosyncrasies and the volatility of the environment that you're coding against. And so it's a pie chart. It's probably not well represented as a pie chart, but it sure is pretty, isn't it? So the point is that if you introduce a library into your environment, then hopefully the library will abstract out a lot of the other failure points, so you can rely on the library to take care of the environment for you, and you can focus on the development of your stuff. Now, when it comes to debugging, this kind of ends up working against you in some situations, because to debug really effectively in a web development environment, you have to understand the web development environment. And a library's job is to abstract that out. And so we try really hard to make it so that you won't have bugs to deal with, but you probably wouldn't be here if you didn't have bugs that you had to deal with. So there's a separation of the separation of sort of two categories of bugs. One is the bugs that are in the environment itself, maybe in the browser or in the library that you're working with, and the different idiosyncrasies there. And then the other category are the bugs in an understanding of the problem space that you're working in, and just how you are actually applying the library and your understanding of the environment into your code and writing your code. So from the library's perspective, at YUI2, we are really trying to make it your fault, okay? And that's, nothing personal, but it is really kind of for the good of the web that we don't have the bugs, but that the bugs exist in your environment. And that actually makes them easier to debug, because if it's just an understanding of the library piece that you're missing, then you have fewer points to say, I'm having a problem, this is where I look. Instead of, I'm having a problem, this is where I look, and this, and this, and this, and also I have to test that on the different browsers, and so on and so forth. So YUI3, we really focused on making the API consistent so that we would avoid the need for developers to keep going back to the documentation to say, oh, wait a minute, this particular widget or this particular module has an API that looks like this. And this one over here does very similar things, but the API to do it is different. And that's just a nuisance. And so for YUI3, we really tried to focus on unifying that API so that it would be intuitive and reliable, that you just think you should do it this way, and you're probably right. Interoperability, we haven't really had an issue with that. We're classically pretty good with that. And documentation, of course, is one of our pride points. We definitely pride ourselves on the quality of the documentation that we have, especially in YUI2, over 300 examples, user guides, everything like that. YUI3 is still new and it's still young, and while we definitely put effort into the documentation, and hopefully that shows, we obviously have a lot of work to do there. But that's also a point where you guys can come in too. If you have questions about documentation, and because it's an open platform, you can just give us documentation for everyone else's benefit, and we'll love you for it. You know, something had to go wrong in a debugging talk, right? Hopefully this is it. So then, of course, we also have our own bugs, right? Which of course we're trying to discover on our own before you find them. But there's still a chance that you'll find them before we do. So when we're debugging, this is the stuff that we have to work with. We have inspectors, which can be used for looking at the DOM, looking at the CSS that's applied to things. There are other little pieces of the puzzle that various different inspectors offer, maybe looking at the network transactions of those sorts of things. We have the console, which is really terribly useful. It's the central point for logging. Logging goes into the console, and also consoles typically have an input device as well, so that you can type something into the console to verify an assertion. Either just looking at the page and then type something into the console, or when you're in the stepping of debugging, then you can do a quick inline assertion, or maybe even use the console execution to change the state of things while you're going through a process. If you've reached a point that's failing, then maybe you can make a change here and then let it go through and see if it works that time, and then woo! And of course, there's the debuggers. I do make a distinction between the debuggers, the console, and the inspector. The console is very integrated into the debugger, but the debugger, what I think of it as a debugger, is the piece that steps through the code. So it is the engine that hooks into the execution of your JavaScript on the page, that you can say, this is where I am, and I want to say, step by step, run this line, run this line, run this line. And kind of last line of defense is the community. So if you've done your due diligence and you've gone through these things and you're up against a wall and your head's about to explode, there's a lot of community support out there, and we're more than willing to help. So these three things are generally packaged together. Most of the developer tools that are out there for the various browsers come with all three of them, and we'll get into those now, but we have one exception coming up here. So this is Web Inspector, which is the debugging suite that comes with Safari 4. I think it may have come out in later versions of Safari 3, but Safari 4 is wonderful, by the way. So Web Inspector here has an inspector device where you can see the DOM is being displayed in its tree, and you can see the CSS that's applied to the particular element that is highlighted. You can see which styles have been overridden by rules of more specificity. Here's the console from IE8's developer tools. The developer tools came bundled with IE8. We were very grateful for that. They did a great job going from kind of zero, I guess, to a pretty decent set of developer tools bundled into IE8. And like I'd mentioned before, here is the input that you could use in the console to execute that stuff. And incidentally, the multi-line mode is my personal preference. I find that it's useful for writing larger blocks of assertion code and testing the output of that. So then here's your debugger here, and you can see there are settable breakpoints at the line numbers in the execution of the file that you're looking at. In this case, you can see I'm looking at the file enhancedtable.html. I think there we go, laser right there. And you can step through that with these various run controls. So just the standard suite of stepping controls are a continue button, in this case as an arrow, a step into button, which will allow you to jump into a function and continue stepping through the individual lines inside of that function, and then the step over button, which will not go into the function. It will just execute that and give you the return value. And then finally the step out button, which will say if you are inside of a function, if you stepped into a function and you've seen enough, you know, it has 200 more lines of this function. It's really crazy to be written with 200 lines inside of a function. But you're done there and you want to come back out. You can hit the step out button and it will jump you back out into the calling function. Typical of debuggers also, you have a watch area or a locals area, which will expose the variables that are in scope at this particular line of execution. And so inside of this function scoping here, we have a this object, and we have the variables column, conf, container, et cetera, et cetera. This is actually a YUI2 data table page that I put together. Stack. So this is really useful actually for finding out where you were called from, and maybe something existed higher up or something went wrong higher up in the stream. So what the stack does for you is it is a list of the call stack up to the point of execution that you're at right now. So I don't actually have a slide that shows the call stack, which would be nice probably. But you can say, right now I am at this line of this function execution, and this function was called by this other function. So you can actually jump in the stack trace there to that other function to see where you are in that function, and so on up the chain, so that you can take a look all the way up the chain to say where exactly did stuff start breaking down. So the big powerful tool here, of course, is the watch tab that shows you the state of your variables and things. And you can also add new watches. In Firebug, in this case here, you can add new watches up there. So if something is maybe in a calling scope, or it's maybe a variable that's coming in from a closure, it's not immediately listed in this list of things, but you know that it's there or it should be there, you can just add that variable, for example, as a watch and get the value of that. And it won't break anything if you try to watch something that isn't there, which is nice. And some of the debuggers also give you this list of the breakpoints that you currently have in the system, which is nice because generally you'll want to set breakpoints at the parts of your code that are relevant or interesting to what you're trying to find. And so if those might be in disparate places through different files, then having this central point to say, actually jump me over to this file to that other line, jump me over to this file to that other line, it's just a directory of the interesting points for your stuff. So this is Firebug. This is the debugger in Firefox. Well, yeah, I guess it's fair to say. This is the debugger in Firefox. And it's also in my opinion, it's the best debugger available right now. It certainly has its quirks and its nuances. It is software. It has bugs. But it's a hell of a lot better than alert debugging. And so Joe Hewitt wrote this a few years ago, sort of scratching his own itch. And I believe there's a YUI Theater video of him introducing a prior version of Firebug. And it goes into some detail about some of the niceties that Firebug has for you and techniques that you can use inside of Firebug specifically for debugging things in that environment. A lot of that still holds true today. So in Firebug, as a suite of tools, here are your inspectors. You have an HTML inspector to look at your DOM. You have a CSS inspector to look at the individual style sheets that you have. The DOM inspector is actually an inspector of the global object, and so your window, right? So this is where you can look to see, hey, I've accidentally created 30 global variables. That's not good. So let's find out what's going on with that. But say, for example, in YUI2, this is where you would find the Yahoo object, right? And so if you were namespacing on that Yahoo object, then you could dig into the Yahoo object and all of the properties that were stored on that namespace using the DOM tab. And of course, here's the console. And here we are in the script tab for the actual debugging step. Safari has Web Inspector. The Elements tab there is your DOM inspector and your CSS inspector, as mentioned before. And down here, there's this really intuitive button right there that says, hey, this is how you view the console. I don't know how that one slipped out. And then, of course, we have the Scripts tab there. Opera has Dragonfly, which is kind of a new player in the game. Is architected kind of differently, but generally speaking, the web development tools in the browsers today are patterned after Firebug. So a lot of those same interaction patterns and grouping of things follow those design patterns. So Dragonfly, you have the DOM inspector there. In this case, the DOM inspector is actually what we would think of as the HTML inspector in Firebug or the Elements inspector in Safari Web Inspector. Error console is your console, and the Scripts tab for doing your debugging. In IE8, which offers us both a view into IE8 proper and IE8 in compatibility mode, and its other various rendering modes. There's the developer tools, which you'll see actually they tried to make it look more like Firebug, which is admirable, I guess. And you have your HTML tab, your CSS tab. Your console is actually in as a child of your script tab, and of course your script tab for doing the debugging. So what about IE6 and IE7? They don't have baked-in debuggers, nor do they have baked-in inspectors or consoles. So you have to rely on external software for those. In my case, I actually prefer this. I haven't used a wide variety of debuggers for IE. You find one that works for you, and it gets you there. So in my case, I went for the world's longest product name, which is Microsoft Visual Web Developer Express Edition. This is 2008, running out of room on the slide. And this is just the debugger portion. Well, it's the debugger and the console portion as well. In this case, what you probably can't see down here is this is the little tiny word output. There's a lot of different views on what's going on in the system, so it is built as an external application that hooks into the IE process, so that it has a lot more power and flexibility for doing the introspection of what's going on in the system. So in IE's particular way, or Microsoft's particular way, they give you all of them at the same time. But we still need some inspectors as well, and so that's where the IE Developer Toolbar plugin comes in. By the way, both of these are free, and they are available just, I think, on MSDN. Just do a web search for either of them, and they'll come up, and they're free and pretty easy to install. IE Developer Toolbar adds this little arrow icon up into the navigation bar, and clicking on that, it opens up this area down here, which is basically just your HTML inspector. It gives you some CSS, some understanding of CSS, but not the granularity of control from the other inspectors. But it, again, is a hell of a lot better than alert debugging. So across the browsers, at least across the current A-grade matrix, there's pretty good representation for developer tools. And so despite the fact that the environment that we have to work with is pretty hostile, we actually are fairly well equipped today to deal with that. I didn't mention Chrome in there, but Chrome has a similar set of developer tools to Web Inspector and Safari. So let's dive in. So here we have a good use for the inspector, where you don't actually have to be stepping into code or something. Is just maybe something in your page isn't showing up. You suspect that either there's something in your code that is missing that's adding it to the page, or maybe something in your code is removing it from the page, or it's not properly being added in the DOM. But the first thing that you should do is use the inspector to see if it's in there in the first place, right? So just open up your HTML inspector, look at your DOM, try and find the thing that you're expecting to be there, because it might be there, and maybe it's just not visible, right? So verify it's in the DOM. If it is in the DOM, then you have some more drilling that you can do in the inspector side of things. If it's not in the DOM, then it's an appropriate point to jump into the debugging part that introduces that DOM structure into the page. So while we're in the inspector land, so a lot of the inspectors have a function where you can hover over an element inside of the inspector and it highlights them in some way, which is useful to show you that it is present and where on the page it is present. Then you can select the element to do the CSS inspection to see if there are missing or overridden styles. So maybe there's a display none that wasn't being overridden by some style that you were trying to apply, and so it's not showing. Or maybe there's a problem with the stacking context that its Z index is hiding behind something else, right? And finally, if everything looks fine in that element's CSS, you can then start walking up the element's ancestor tree to check the CSS of those individual elements and see maybe there's something in the CSS that is causing this thing not to be there. And a lot of the debuggers give you the ability to just disable some certain styles or maybe change the styles on the fly so that you can just kind of poke at it and see if you can make it work. And then the last step is to make a reduction. I'll talk a little bit more about reductions later, but they're kind of the last line of defense, but the first thing that you'll want to do before you ask for help, please. So some usual suspects that you'll see in this case where something just isn't showing up or there's a problem in the display of some case is that you have a display none or visibility or any of these things can cause a little havoc in the system. So just keep an eye out for those. So here is representation here. So I have this element in here, this pop-up, but it's not displaying, and I don't know why. It seems like it should be displaying, but it's not there. So I'm going to do a search first to find pop-up because I know the thing's ID is named pop-up. So I'll just do a search in there, and the web inspector will jump into the DOM at that point, find it for you. It's nicer than just drilling in by hand. And take a look at that element, highlight the element, and then take a look at the CSS that's associated with it. Verify that the CSS looks to be in order, and then start walking up the DOM tree, right? So now we select its parent element, and we look over here, and we see that there is another style rule that's being applied to all the descendant divs inside of the back classed elements that's sending this way off the screen to the left. So it's not being displayed, and it's overriding the style that we had applied to our pop-up here, which just put it at left 100. So like I mentioned, you can just poke at it and see if you can make it change. So in this case, you see, if I just disable that left style there, then it allows this one to come through because it pretends that this one is no longer in the cascade for that particular property. And so this is useful for giving you guidance that you need to increase the specificity in your CSS because you have to contend with something else on the page, which is applying rules for the elements that you're working with, right? So now we can move on to using the console. So the console, I'm going to talk primarily about the logging mechanism of console for now, and when we get into working with the debugger, we can use the console a little bit more. So the ways that you can do console logging, of course, there's the classic of alert, and in a lot of the development tools now give you a console log. And that's sort of the standard is being developed across the browsers now. All the new versions of browsers are coming out with a console object that typically has a log method. But they don't all have a log method, and certainly legacy browsers don't have a console object. And so you could be introducing a bug into your system by including a line console log in your code. And oops, I forgot to take that out before I pushed it live, and boom. So the Y object, the YUI instance, comes standard with a log method, and the log method normalizes the APIs for the different native console objects under the hood. And if a native console object isn't there, it just doesn't do anything. So you have pretty good A-grade coverage, well, most of the A-grade coverage, I suppose, for just hooking into the native console if you wanted to check the status of what's going on in your application. So y.log signature looks like this. You have the message that you want to print out, followed by a category like info, warn, error, or if you wanted to categorize it differently. And then the source, which we like to include to say this is where this message is coming from. And this is actually a chunk of code from Slider, so just to give you an illustration of the code that we write actually has log statements in there. So if you wanted to just get an idea of what's going on inside of our stuff, then you can just turn the debugging on, which I'll talk about, and the console will start to spit out those messages for you. So you can get an idea of maybe where something is going wrong based on the logging that you have. Additionally, I mentioned that that the console object doesn't exist in all native browsers, which means, or rather it doesn't exist in the browsers natively, which means that we don't have a consistent coverage if something is breaking in a browser that doesn't have the console object. And so we created the console object and the console widget here as a developer tool that also listens to y.log, and it renders the messages in the console. It's similar in YUI2 to the logger, the log reader class from YUI2. The difference here is, of course, that like all of the rest of the widgets in YUI, it is also cross-browser. It is configurable and extensible. You can do all sorts of things with it. One of the things that was pushed out actually with GA, maybe even with Beta 1, was the filtering plugin. So you can add some filtering onto your console. So here are the categories that I have, and here are the sources that I have at this point. And I could just check or uncheck those to maybe reduce the noise in the system that I'm seeing in the logging. So when you start a need to get into the code side of things, or even just to manage the logging noise that's going into the system, you'll need to turn on sort of the debugging functionality inside of YUI. And you'll do that by configuring the YUI instance. And that configuration is passed in as an object into the YUI class constructor. So these are the different things that you can use for setting up your debugging environment. But today I'm only going to focus on these two, because these two get you pretty much all of the way there. Just note on the first thing of their debug true is actually the default property, the default value for that property. So you don't actively have to turn on debugging. It's just on by default, but you can turn it off, in which case it doesn't matter how many log statements there are in the code. You will not get anything written to console. You will not get anything emitted to the YUI console. These are the two that are key. And this is the setup that I have found to be particularly useful for doing debugging in YUI 3. What the filter property does is it overrides the default value for the loader, which when you say use these modules, it under the hood is going to say, all right, great, I'll get all of those modules and I'll glom up the min versions of them and I'll load them in off the CDN. The min versions are not very easy to debug in, and so we need to change that, and the filter is how you then specify that I want a different version of the files that I'm asking for, the modules that I'm asking for. So the filter is how you change the modules that the type of module that you're loading down. Now, filters gives you more granular control over which modules are receiving which version or which mode of the module you're receiving. And so in this case, what I have here is I have a filter set up to say, don't give me the min versions, but I don't need the debug versions either, because that's an awful lot of log statements from everything and all of their dependencies. Instead, I have a notion that something is probably going wrong that's related to the attribute module. And so I'm going to specifically request the debug version of the attribute module. Not of its dependencies, but just the attribute module. So in this way, you can say, you can really reduce the noise that's going into the logging subsystem. The other configurations that were also available offer you different ways of doing that filtering. But this I found is a pretty successful way. And of course, as an object literal, you can specify that I want the raw version or the min version or the debug version of anything that you specify in filters. So the environment that this sets up for you is that all of the code that you get loaded onto your page is readable. It's not minned, but there are log statements specifically for the module that you're looking for. Do you have a question?
Yes. If you write your own modules, how do you enable this ability as well?
I'm not sure if when you write your own modules, if the gallery, well, the build step that's necessary for a gallery module goes through Builder, and so it's going to have an understanding of the debug and raw and min versions of the files. But if you're writing your external modules, or if you're writing your own modules, and you're just including them in themselves or by themselves, then you'll want to turn off, you'll want to disable logging using some of the other configurations that I specified, specifically log include or log exclude. The documentation for that is available on YDN, and you can look in the console examples. There's actually an example showing you how to do this. So let's start using the debuggers then. I'm going to primarily focus on using Firebug just because it's easy for me to use. We'll start with a little low-hanging fruit. Before we even get into the runtime errors, let's deal with some compile time errors. So trailing commas break IE. This comes up time and again, over and over and over again. If you load up a page and it doesn't work in IE, and it gives you the expected identifier string or number error, you have a trailing comma somewhere. So if you have an object that you're declaring, so foo and bar, that's your culprit right there. This is the reason that your page is not working. We love that. The same applies for arrays also. So just be wary of your trailing commas. Another thing is a race condition that's that IE is particularly volatile with. Probably all of you are familiar with the dreaded operation aborted error, which is when you try to modify something in the DOM that is not finished loading yet. And so maybe you're trying to append to, you're in the middle of a div, and you're, as the page is being parsed, some JavaScript is being executed, but you're not finished loading the page yet, and there's some more DOM structure that's going on, and you try to append something into something that's not finished loading yet, IE will just barf and fall down. So the key there is to wait until that thing is ready. There are a lot of different ways to do that. So here's a few of them. You can wait for the window on load using the event syntax of y.on load for the window object. We also emit a DOM ready event that you can hook into. This is very reminiscent of YUI2 with the event on DOM ready to provide your callback there. If you want a little more granularity of when something is ready, you can hook into content ready or available for a specific element. You can see the distinctions between those in the documentation. And finally, you might just not need to add stuff to the end. Generally speaking, the safest thing to do might just be to put it at the top instead of the bottom. You know, if you're positioning something absolutely, it doesn't necessarily matter if it's at the bottom or the top. So maybe just try to prepend it into the content rather than append it into the content. So let's move on to the next problem, which is, where's my data? This goes back to the discussion of asynchronicity in the system, and particularly how XHR is asynchronous. And this won't work because the order of operations here is that the data variable is defined, the I/O operation takes place and issues out a request. It then moves on in the code to say, execute the display data function, and of course, I don't have my data yet because I just issued a response. I'm not waiting for that. That is best practice. Don't try to make it synchronous. This is how it's supposed to work. You just have to understand that this is how it's supposed to work and work with it. So here's an illustration of that and how you might discover this on your own. You have this particular setup. I'm going to set up a couple of breakpoints in my code, and then I'll just reload the page. And you'll notice that we get, wow, that went really fast. So let me just start that over again. Yeah, baby. So I'm going to set up a couple of breakpoints here at the two interesting points in my code. I'll reload the page, and I'll see that the display data got called first. The other one did not get displayed, and so I'll continue the execution all the way through. And then just to verify that that function is actually being called, I'll try reloading the page without that breakpoint. I'll see that it is called. So in this case, the console object in Firebug, the console also exposes the XHR transactions, and it shows you that, hey, this request went out. It came back with a 200. Here's the contents of that request. So it's a great way to verify that you did send a request and you did get data. You just may have done something out of order. So the takeaways here are when you are going into your debugging session and you're setting your breakpoints, expectation is where you want to set your breakpoints. I have an expectation that my code should be in this state at this point. That's where you want to set your breakpoint. And then the specific tools and inspectors give you ways of looking at the things as you're going through. So using the console or net tab in Firebug or the various other debuggers to see the contents of the XHR transaction. So another problem here, I'm kind of running out of time, but another problem is maybe you get an X is not a function. So in here, oh yeah, the X is not a function actually comes in many brands. Depending upon which browser you're in, it might come across as object does not support this property or method in IE, or in Web Inspector, which is really friendly about it. They said, hey, this function that you called right here, named this, isn't defined. Look, it's not a function. You're like, oh, well, thank you. I know exactly where to look now. So an easy way to address these sorts of errors is to just set break on all errors. A lot of the debuggers actually do this by default, but some you can set manually. I'll show you where. Always a good idea to check the documentation because maybe you're missing something in your environment setup. And the dependency configurator is relevant somehow. So here's how you set break on all errors in Firebug and Web Inspector. This arrow should be pointing at that, which is also a nice little icon saying a stop sign with a pause on it. So here is a sort of an illustration of that. The selector is not working, right? So you have this code here. You just want to take the first element, the first div that contains the string YUI, and add a class to it, or maybe change its content or something like that. And you're using the node, so you have your selectors going on. But why is it not working? The reason it's not working is because YUI3 node comes out of the box with CSS2.1 selectors. In order to get the power of CSS3, you have to add that module on. And what's happening here is that when you include this module, it changes the subsystem to have more flexibility. So, it can be kind of tricky, and this is one of those situations where you have to understand a little bit about YUI, and the documentation is going to come in handy in this case for finding out why something might not be working. So in this case, this is the missing module problem. So the symptoms of missing module problem are you either get a runtime error, such as we would have gotten in the previous case, because that y.1 call would have returned null. And trying to call a function on null, boom. Or you have maybe a cross-browser failure, and this is more relevant to event normalization. So when we do event normalization, we have specific modules that address events of interest. But because of the guidelines for modularity in YUI3, we might not include that module in the default. You might have to specifically request that module for that specific event normalization. So if you're testing in one browser that has native support for this event, or has a non-buggy implementation of this particular event, it works. And then you try it in another browser and it doesn't work. probably because there's a normalization module that's missing from your environment. So the usual suspects, like I said, we have selector CSS3, and then a couple of the event modules. So when we use y.1, y.1 will emit an error just because you're trying to execute a function on null because it couldn't find anything. But y.all is a case where it seems like it'll get swallowed. Well, it seems like it should work, but there's no error out of this because there shouldn't be an error out of this because y.all returns a node list always. It always returns a node list. It's patterning after the DOM, get elements by tag name, those sorts of things will always return you a list of things, even if it's empty. So in this case, we're saying add class on this empty collection. Sure, we'll do that, no problem. So again, in this case, you're missing selector CSS3, but it might be a little harder to discern why or where, right? Because you may be well past this code before you notice that something is not right, that element or those elements don't have that class on them. You know, what's going on here? So missing module. So in this case, the y.all returns an empty node list, and the usual suspects are the same. So the step one, break the chain. So chaining is really useful for creating code that might be readable in sort of a sentence sort of way. I want to take these elements and do these things with them and then this. But just don't make run-on sentences, right? I want to do this, and then I want to go to the store, and I want to get some eggs, and I want to come back, and I want to talk to my cousin Larry, right? So chaining can really introduce that sort of dangerous environment, right? And it's prone to bugs, and it's also particularly prone to bugs that will get swallowed somewhere along the chain, and then maybe nothing goes wrong for the rest of it because you're dealing with empty node lists. And so a whole lot of nothing happens for the rest of the chain. So break the chain if you see something that's, you see some area in your code that might have a lot of chaining and you know that something is not going right in here, just break the chains apart when you're debugging it into separate execution lines, and then set your expectation breakpoints. And another resource is if you're using y.all, dealing with node lists, you can always test the size with the size method to see, do I have something here or am I at 0? So here's an example of that. Here I have the y.all, and man, I'm making these animations really fast. Isn't that great? So here I have this chained thing. The div contains YUI. I'm going to set the content to gotcha, but that's not happening. So what I do is, first step is I'll change that, break the chain, set my expectation breakpoint, reload the page, and now once I'm there, I can either set a watch to say, look at the list size and see that I have 0, or actually the node list has a toString method that says I'm not bound to any elements. So there's an arrow here. So let's see. So this is a good use of documentation, or a good place to find the documentation. So we'll talk about another problem, which is I can't access the Y. Right? So the YUI environment is built on the principle of sandboxing. We're not exposing anything to the global environment on purpose. And YUI, unlike YUI2, is instance-based, and it's not this shared global that you just assign all sorts of stuff onto. So maybe if after your page is loaded, you want to use the YUI API to look at the page or inspect something from the page in console, you can't because you don't have a YUI instance in hand. It's all transitory. So the simple problem that you can, or the simple solution for this, so this is an illustration. So I'm just in my console and I say I want to look at this div, and it doesn't have a Y to reference. So the first thing that you can do is just assign the return value from the YUI.use statement to a local variable, and then it'll be there, right? It's really as simple as that. If you have the potential for maybe a race conditions going on, or you're concerned that there are race conditions that might affect things, then you can also use the combo URL to turn on the synchronous loading of modules instead of using the loader to dynamically load things in. We'll talk about that in a second. But the most important step here is to undo those. This is a debugging step. We don't want that sort of stuff to go into production because there are performance impacts with that, and we just don't like polluting the global namespace. So the dependency configurator is useful here, incidentally. This would be how you would change to a synchronous loading strategy if you wanted to see that there were or were not race conditions going on in your page. You could just go into specify the individual modules that you wanted and then just copy this script tag onto your page instead of just the YUI seed file. And now your YUI use will just load the modules that are already on the page, and everything will happen synchronously. So there isn't some loading thread going on and DOM parsing thread going on here and a variety of other things that you have to worry about. So now the YUI instance is available to you on the console that you can use that. Again, don't let that stick around. So the last thing, maybe the last thing, one of the last things that I want to talk about. So the node facade and nodeless facade are sitting on top of DOM nodes, but they are not DOM nodes. So if you have to maybe work with another library, or you have some other need or function that just needs to hold on to those DOM nodes, or if you're just debugging something and you're inspecting something in step 5 of your debugging procedure, you want to look at the properties of the DOM node. If you have a node instance in hand, you don't have those properties because it's just this thin veil over the top of this node. And similarly with node lists. So the way that you can get at those are using the _node and _nodes properties. Now these are properties, they're not attributes, they're actually hung directly on the object. And they are the DOM nodes so that you can access for whatever. There's also these utility methods here, node getDOMnode and nodelist.getDOMnodes. And those will take an HTML element or a node, and they'll just make sure that it returns you either null or empty array or the actual DOM node itself. And let's talk about the community, kind of the last line of defense. Community, we have a lot of that going on. The YDN JavaScript list, primarily for YUI2, but we pay attention and we answer questions. So you ask a question, you'll probably get an answer. That's that and the YUI3 list, which came out fairly recently, are Yahoo groups. We actually recommended to migrate those discussions onto YUILibrary.com, the forum on there. And that's pretty much happening. So the YUILibrary.com forum is kind of where it's at. You can also look on Stack Overflow, ask questions on Stack Overflow. A lot of us pay attention to that. And finally, we do have an IRC room in Freenode. You can just go in and ask questions in there. And there's a growing community in there of support. A lot of the people in there are still kind of focused on YUI2, but there's definitely a new surge of people that are asking and answering questions about YUI3. The key about working with community, though, is help us help you. Don't say, my page is broken. Give us a reduction. Give us a link to the page. There are all sorts of things that you can do. We will love you if you create a reduction, you link it publicly, you send us the URL, the function name that is failing, the line number, and some idea of why it's failing, and the expectation that you have, and maybe the context of it. The more information that you give us about the problem, and the less information that exhibits the problem, the better, right? So this, of course, we like you a little bit less and less as you give us less of that information, but we never really hate you until you just outright insult our mothers, which, sometimes it's pretty close to that. Before you ask, though, and before you do these things, check the forums and check the archives, right? There's probably someone has asked the question before. And you can get a lot of information out of the forums, even across older versions, right? So this answer was 2 versions ago. It still might be relevant because the API is fairly well baked, and we aren't going to be changing that a lot. And then reduce, right? So this is totally key. Before you ask questions, unless it is impossible, which I can't imagine why it would be, reduce the problem. So you have this really big, rich application going on, and this, this asynchronous XDR load this other module, which then loads another page into this iframe, and the scripts that should be executing inside of that iframe should then be instantiating a YUI2, and then some classes out of YUI2, which then go out here, and they also have some YUI3 going on in there, and then at the end of something, well, this DOM element isn't displaying. Please. Okay. Yeah, just pare that down. Do some work up front to try and reduce that down so that you can just go through the process of elimination, cut it in halves, just take out swaths of HTML, swaths of CSS, piece by piece, just cut it in half and keep cutting it in half until the problem goes away, and then start isolating in on that. It's a lot of due diligence that we beg you to do up front, because it's an easier problem for you to solve contextually because you understand the problem space that you're working in. And so there's a lot of ramp-up time for us to help you if we have to understand a lot about your problem space based on the complexity of the app that you're asking for help on. So gist is create a gist of it, or a paste bin, or a pasty. There are a lot of sharing spaces for where you can take code snippets and post them up publicly. If you have a private domain, or you just can't share this application publicly, then drop a code snippet on there. Really, people aren't going to go there and say, aha, I now have the corporate secrets for this other person in this company. This is great. And it's just a code snippet. Just share the code. If you have some sensitive data in there, just mask it with some bogus data. So Gist is a service of GitHub, which is awesome and may have been mentioned previously in other talks and will undoubtedly be mentioned again. But Gists are a service of GitHub, and so they have versioning and forkability. So when we're trying to help you, you give us a gist, we can just fork your gist and make some changes, update it, and then point you to our fork, and you can see what changes were made, and you can watch the evolution of the code. And there's also that traceability of the process that it went through. So if in the future someone has a similar problem, we can say, well, this was actually solved in this gist over here. Just look through the different revisions in the forks to see sort of the evolution of that discussion. And finally, don't be afraid to read the source. It's library code, yes, but it's software. And so it has bugs, but we really do try to make it fairly readable, fairly understandable. It's not some cryptic voodoo in there. Under most cases, there are some modules that definitely have some voodoo in there. But generally speaking, it's well commented. It's syntax highlighted up in our API docs. Just read through it. If for nothing else, it's a good illustration of maybe best practices in coding. So read the source. It'll also give you some introspection into how we build things, and so maybe how you should build things as well. Or you should build things to work well with the stuff that we build. So preventative measures, while I don't have any more time, you should always run your code through JSLint. If you're not familiar with JSLint, you should be easy to find on a web search. Doug Crockford put together this program that inspects your JS code, looking for bad practices or just outright errors. And it hurts your feelings, but it is really helpful. Use markup validation. I can't tell you how many times we've tried to help somebody maybe in the IRC channel where they had a div inside of an A tag, right? So it's block a level element inside of an inline element. It seems like it maybe should render all right, and it conceptually doesn't seem all that bad, but it's invalid HTML and therefore becomes tag soup, and therefore whatever happens is not expected. So use HTML validation and CSS validation. And finally, set up some tests. YUI, the test suite in YUI is awesome. It is totally the one of, if not the best, testing infrastructure for JavaScript available. And as a final note, in case I didn't mention already, add tests. You had a bug, right? Make a test for it. And then in the future, after you have changes, you already have that case covered. So add tests. If you have a bug, add a test for it. It's very simple. And then another final thing is to remember that it is your fault, and add tests, seriously. So these are the images that I used in my slide. And that's all for me. I did go a couple minutes over, but I'll stick around for questions if anybody has any questions. Maybe I didn't cover something that would be of interest. Anyone else?